All right, so for the final one that I'm going to walk through with you all the way, and then I'm going to set up one more. But we want to look at what happens. This is in factored form, but this time we have multiples. And so I'm going to kind of write this in a backwards sort of way. I'm going to rewrite this as an x plus 8 over, and then what's being squared here? You actually have the quantity of x squared, and then an x squared plus 9 to the first. Okay, so this is what's being squared. And so you need to look at what's inside the parentheses in order to decide how to set up your numerator. Okay, now with the multiplicity, meaning I've got factors that repeat, what we're going to do is walk that down as well. So this is an x that is being squared. So what I'm going to do is create an x and then an x squared from there. So I'm going to take whatever's on the inside of the parentheses and I'm going to write it as many times as indicated by this exponent. In other words, if this exponent was a 3, I would have an x squared, x to the third. Okay? But it's important to notice what you're squaring. I'm only squaring an x. Over here, I've got an x squared plus 9. It's only represented once. Okay, so I'm going to go ahead and say, plus. And then I've got an x squared plus 9, but it's represented once. Okay. Now, the reason I keep screaming about paying attention to what is in the parentheses or what's being squared is because whatever is being squared is what you walk down. So in other words, this x has multiplicity. So I'm going to have an x to the first. So he's going to drop to an x to the 0, which is just a. Well, this one is an x to the first, because that's what's in parentheses. But I represent the multiplicity of 2. So I know that's kind of weird. So you would think that you would put a bx plus d here, but don't. What's being squared? Only the x. Okay? So my numerator is just going to take the form of a b, because this 2 represents the multiplicity of how many times this was used as a factor. This is being used once as a factor. So now I go ahead and say, well, drop this thing down. So this is going to be a cx plus d. And I know that's kind of weird because, like I said, you would think that you would walk this down to a bx plus c, but you're only dropping down the quantity. You're only dropping down by degrees whatever's inside the parentheses, and we just don't write the parentheses here. Okay? So it's important to notice that the x has multiplicity. So this x has multiplicity. So I drop down from the x. So this is a b. So now what I have is this thing is going to equal x plus 8 over x squared and then x squared plus 9. So if I walk through and multiply everything by x squared times x squared plus 9, that means I'll have an x squared plus 9, x squared plus 9, and then x squared times x squared plus 9, and then this one too, which means all of that's going to reduce, and that's just going to leave me with an x plus 8 on the right. Now, I lost my favorite blue pen that I broke. All right, so here we go. What reduces here? Only a single x reduces here, so that's going to leave me with an ax times x squared plus 9. Okay, the x squareds reduce here, so that leaves me with a b times x squared plus 9. The x squared plus 9s reduce here, so that leaves me with, hang on, I'm out of control, just the x squared. And then that's going to equal my x plus 8. So now I'm just going to organize. Okay, and this is the portion that I'm kind of sort of wanting to reiterate here. What did you square? You squared a single x. And so you got an x to the first, so you drop it down to an x to the 0, which is just going to be a. You have an x to the first again, and then you drop it down to an x to the 0, okay? So this one I'm going to do with, this is going to become ax to the third plus 9ax plus bx squared plus 9b plus cx to the third plus dx squared equals x plus 8. So the greatest degree I've got is an x to the third. So I've got an ax to the third. I got no bx to the thirds. And I've got a cx to the third. And I got no dx to the thirds. That was like incredibly great English. And then this is equal to no x to the thirds. Okay, so this is done, and everything else is taken care of. All right, so now drop it down to the x squareds. I have no ax squareds. I've got 1bx squared. I've got no cx squareds. See? And then I've got 1dx squared, and that's going to equal no x squareds. So he's done, and then he's done. So now I'm left with just ax's and a b. So I've got an x row, so I've got 9 a's, x's. I got no bx's, no cx's, and no dx's. So these are all 0, 0, 0, but I got 1 over here. Okay, so I've got a single x over here. And now he's done, so that leaves me with 9b equals an 8. So I've got no constants, no constants, no constants. So that was the hard part. So we've got 4 rows, and we've got 1, 2, 3, 4, 5 columns. Okay, so what are my coefficients? I've got 1, 0, 1, 0, 0. And then my second row, I've got a 0, 1, 0, 1, 0. Then I got a 9, 0, 0, 0, 1. And then I got a 0, 9, 0, 0, 8. So if you'll notice, you've actually already got 2 answers. Because if I divide this entire row by 9, then a single a will be 1/9. If I divide this entire row by 9, then a single b will be 8/9. Okay, so I'm going to slap this thing in my calculator. So, wait, what do I have? All right, clear. So I've got my matrix. I'm going to go to edit. I need 4 rows, 5 columns, so I need a 4 by 5. So I've got a 4 by 5. And then I'm going to enter this thing. I've got 1, 0, 1, 0, 0. So 1, 0, 1, 0, 0. I got 0, 1, 0, 1, 0. So 0, 1, 0, 1, 0. And then I've got 9, 0, 0, 0, 1. And then I've got 0, 9, 0, 0, 8. Okay, so I've set up my matrix that you couldn't see, but there it is. I'm going to X out of there, come back in. So remember, go to edit first, then math. So I'm going to go over to math, scroll up to option B, which is reduced row echelon form. Go back into matrix. So I started with edit, then I went to math, and now I stick with names. So I want to do matrix A, and I wanted that in fraction form. And so what I have is an A value of 1/9, a B value of 8/9, which we said a while ago. My C is negative 1/9, and my D is negative 8/9. So when I come back up in here, this is where I'm going to rewrite this mess right here. And I'm going to do it in this box right here, which is going to be, I should have skipped one more line, sorry. All right, so my A is over an X. My A is 1/9. So I've got 1/9 over an X. Plus, what is my B over? My B is over X squared, and my B is 8/9. So I have 8/9 over X squared. Plus my C is a negative 1/9. So I've got a negative 1/9 X. And then my D is negative 8/9. So negative 8/9 over my X squared plus 9. So those were the original fractions that once you get common denominators and all that kind of stuff and combine like terms, that's what you're going to get back. So the last one, I'm just going to set up real quick for you because it's a little bit, I lost my notes. Hang on, there it is. Okay, so what I have is a 6x squared. So I've got a 6x squared over, and then I've got x minus 4 squared. And then I've got, what do I have? Lost it. X plus 4 squared. I just broke my pen again. Okay, so this time I'm in factored form. I do have multiplicity. I've got repeating factors, so I'm going to have to walk those down. Notice what's in your parentheses. I've got x to the firsts in my parentheses. Okay, so I'm going to acknowledge what's in the parentheses in order to figure out what my numerators are. Okay, so what I have first is I'm going to look at this x minus 4 squared. So I'm going to have an x minus 4, and then I'm going to have an x minus 4 squared. Well, what is in parentheses? X to the firsts. So drop it down to an x to the 0. So this is an ax to the 0 and a bx to the 0. Pay attention to what's inside the parentheses. Okay. The next thing that we want to do is, wait one second, is we are going to do the x plus 4s. So I need an x plus 4 to the first plus an x plus 4 squared. So what's inside the parentheses is an x to the first. So drop that down to an x to the 0. This is an x to the first, so drop that down to an x to the 0. And all of that is going to equal, I am so sorry. All of that is going to equal 6x squared. All right, so I'm going to set this up, but I'm going to let you finish it. So what would my common denominator be? This is my common denominator, okay? And this actually gets a little bit tedious, so just be very, very careful when you're multiplying stuff out. Be exceedingly careful while you're multiplying stuff out. So if this is my least common multiple, or what would be my common denominator, then when I multiply it times this chunk, only one of the x minus 4s will reduce. So that leaves me with an a times the remaining x minus 4 times x plus 4 squared. Okay, on this one, both of the x minus 4s are going to reduce. So both of these will reduce, which is going to leave me with this. So I have b times x plus 4 squared. On this one, a single x plus 4 will reduce. So that's going to leave me with the remaining x plus 4 times x minus 4 squared. And on this one, both x plus 4s will reduce, which is going to leave me with x minus 4 squared. Okay, so from here, it's tedious, but it's just basic algebra. So make sure, I'm going to show you for part A, make sure that you do x plus 4, x plus 4. So make sure you FOIL all that stuff out, and then everybody gets an A. Okay, make sure you FOIL this out. So remember, x plus 4 does not mean x squared plus 16. It means x plus 4 times x plus 4. So you'll have to FOIL this and then distribute that, then distribute your A. Okay, this one, then this one, then this one, then make your rows, and then make your columns, and be very careful. I would check your work. But when you're done, whatever A is will go here, whatever B is will go here, whatever C is will go there, and whatever D is will go there. The only thing you're going to have equal will be a 6x squared. Okay, so you're going to generate an x to the third row, which will be equal to 0. You'll generate an x squared row, which will be equal to 6. And then an x to the first row, which is equal to 0, and a constant row, which is equal to 0. All right, so that, my friends, is 12.5. And just take your time, and I will see you for the next section.